All right. So I'm sharing my screen with you guys right now, and I've got it set up so you don't know who each person is on here as far as the questions you're getting correct or incorrect, and like they got weird names for you, like red eraser, pink car. so so don't worry, nobody knows who's who here. Um, but up here on the top, you see this bar graph, and each one of these is a question, and I realized this about 10 minutes ago, but when I assigned the quiz, I assigned it so it mixed up the questions for everybody. So everybody's first 10 questions are going to be different. But in showing you guys this, you'll see that I'm clicking through here. So this is the questions 1 through 15 is what's showing right now. We struggled on these, and I'm going to go over a lot of these that are mostly red. I'm going to be going over these here in the next 10 minutes. Uh, Whereas the second half, most of them are green, and that's a good thing. It means you guys are understanding that section a little better. Um, so we're going to go ahead and we're going to just jump in and get started on some of these in the front. All right, so I've got a few of these numbers written down that we're going to go over, but I'm going to open it up from the test, so I've got a little more space to work with. Probability review. So I know my numbers are different than your numbers. Okay. So I'm going to put the problem up and then you can kind of see which problem I'm talking about. All right. So question 3 is one that I think only 4 people got this question, but all of them got it wrong. So it says you roll a die and pick a marble. Okay. You roll a die and pick a marble. How many outcomes are possible? Okay. Well, this is the thing. If we look at the die, there are 6 outcomes with the die, and there are 2 different outcomes with the marbles. The way you can get the total number of outcomes is you multiply the 2 together. So 6 times 12, or 6 times 2, sorry, which would be 12 would be our answer. Same way, if I were to say, what's the probability of rolling a 4 on the dice? Well, that'd be 1 out of 6. And then picking the red marble, well, that'd be 1 out of 2. Well, the probability you multiply straight across is 1 times 1 is 1, 6 times 2 is 12. Well, the top of this is the number of favorable outcomes, and the bottom of the fraction is the number of total outcomes, which is that 6 times 2, which is what we got here. Okay. So if they're talking about possible outcomes, you're just multiplying the number of possible outcomes in the first one times the number of possible outcomes in the second one. Okay. All right. Next one I'm going to look at is question number 5. Okay. Letitia randomly selects 25% of 7th grade students in her school and asks them their favorite season. Of the students surveyed, 51 choose summer as their favorite season. Based on the data, what is the most reasonable prediction of the number of 7th grade students in her school who would choose summer as their favorite season? Okay. I look at this question as more of a reasoning question. Okay. For you guys, I'm not going to pick crazy percentages. 25% is what is that as a fraction? Okay. Think about that. Like what fraction of the whole school is that? And 25%, well, where am I? That's 25 after over 100, which is that's 1/4 of the school. Okay. That's 1/4 of the school. Now, what we can do is we could set up a proportion here. Okay. You could set up a proportion and we could use the 25 over 100, but it's easier if we reduce it to 1/4. And I'm going to make it so it's going to be a reducible fraction, so it'll be easier to work with. But we can set up a proportion. We know that when we did 1/4 of the school, 51 chose summer. So we could actually extrapolate that and figure out, well, if 1/4, 51 of the 25%, okay, we could figure out about how many students that would be overall by using a proportion that looks like this. And if you guys remember, when you have two fractions that equal one another, you can cross multiply. 1 times x is 1x or x, and 51 times 4, that's 204. So basically, if 1/4 of the school was interviewed and 51 people, well, you could multiply that times 4 to get about how many there would be if the whole school was asked. And there is an answer close to 204, and it's right there, 200. Okay. Again, you could think about it a lot of different ways. In my head, the way I thought about it was I know that we interviewed about 1/4 of the school. So if I wanted to figure out what the whole school was in my mind, it's like, well, I need to multiply what we have by 4. And that's what we did in this proportion as well. Okay. All right. And the next one, number 6. How many possible outcomes if you choose from 6 ice cream flavors, 3 different sizes of scoops, 2 toppings, and a waffle cone or cup? All right. So this is the same idea. How many things are we picking from? And this is why I like to use these kind of these open spaces for all of our different choices. We're choosing from ice cream flavors. We're choosing sizes of scoops, toppings, and then a waffle cone or a cup. So in our first choice, flavors, how many different flavors? 6. How many different size scoops? 3. How many different toppings? 2. And then how many different, or waffle cone or a cup? Well, it looks like there's 2 choices there, a waffle cone or a cup. To get the number of possible outcomes, you're going to multiply all these together. 6 times 3, which is 18. 18 times 2 is 36. 36 times 2 is 72. Okay. So again, if you're getting those questions where you're looking at those possible outcomes, you got to know how many different things you're picking from, and then you're going to multiply the amount of possible choices in each one. So 6 times 3 times 2 times 2. Again, I did it all by hand here, but you could easily just type that into a calculator and get 72. Okay. Number 7 was the next one I want to go over. Okay, what is the probability of picking an orange marble and flipping tails? This is similar to the example that we used yesterday. But again, same idea. We've got, I'll try and use a scratch pad on this one. All right, so we've got one, two, let's see, 1, 2, 3, 4, 5, 6, 7 marbles total, and only one of them is orange. So we have a 1 in 7 chance of picking an orange marble. Again, this is the same idea we did before. I should have put this down here first, but there's 2 different things we're picking. So we're going to put the probability of the orange right here, 1/7, and the probability of flipping tails over here, which is 1/2. And if we multiply those together, it should give us the probability of both things happening. 1 times 1 is 1. 7 times 2 is 14. All right, I don't like this writing tool is good. 1/14. D is our choice for that one. Okay? And that's number 7. Number 8 is one that I wanted to go over. Same idea here. It says, what's the probability of spinning a, going to the good writing tool. What's the probability of spinning green on the first spinner and blue on the second spinner? Well, on the first spinner, first of all, the spinners are different. They're divided into different numbers. So it looks like on the first spinner, there's 1, 2, 3, 4, 5, 6, 7, 8 sections, and green makes up one of the 8. So the probability of spinning green on the first spinner is, again, two different things, but probably on the first spinner will be 1 out of 8. What's the probability of spinning blue on the second spinner? Well, there's only 1, 2, 3, 4 sections on the second spinner, and blue is one of those 4. Okay, so that'd be 1/4. Multiply these together. 1 times 1 is 1. 8 times 4 is 32. Okay. Now, when we give our answer, okay, it pulls up, if you click on it, it pulls up your math tools here. Okay. So the direction said write your answer as a simplified fraction. Well, this is simplified. 1 over 32 is. But again, click on the fraction button and type in your 1 over 32. Okay. Now I've got all these set up so where if you write down an equivalent decimal, it'll still count it correct. But some of these decimals go on for a long time, and I don't want you to round it by accident and get the answer wrong. So ideally, answer the way it's being asked. Okay. All right, I'm going to get through at least 2 more before we're done here. Okay, so follow with me. Let's see, let's go to 14. On the table below shows the different choices for making a shake at a restaurant. Joey will randomly select 1 dairy, 1 fruit, and 1 topping choice. What's the probability that Joey's shake will be made with ice cream, pineapple, and granola? Okay, so this is one of those things where we've got our different choices. Okay, got your different choices here. So dairy, fruit, topping. Well, what's the probability? We can look at, we're trying to pick ice cream, pineapple, and granola. Well, what's the probability of getting ice cream? Will that be a 1 in 2 chance? What's the probability of getting pineapple? 1 in 3. Probability of getting granola? 1 in 2. All right. So we should be able to multiply straight across. 1. Looks like there's a 1 in 12 chance of that happening. Okay. 1 in 12. So we would go over here and click on 1/12. All right. Same idea though. You got your 3 separate options here, and you got to look at the probability of each one of those things happening. Okay. And then for them to all happen at the same time, you would multiply those probabilities together. Okay. All right. Let's go through one more here. And we're going to go to 15. At a local gym, a random sample of 75 members took a survey about their favorite type of exercise. There are 350 total gym members. Based on the results of the survey, what is the most reasonable estimate for the number of gym members who prefer running on the treadmill? All right, so it looks like they took 75 out of the total number. So I'm going to set up a proportion here where we've got the sample they picked was 75 out of our total number, which was 350. And of those 75, let's say we're trying to figure out who prefer running on a treadmill. So let's look at just that data. Looks like 15 people did. So if we want to know how many people out of the entire population, that's going to have to match up down here, which would be our variable. So we can cross multiply here again. Now this one's going to be a little more difficult. 75 times x is 75x. And 15 times 350. Now, even Mr. Newberry can't do all that in his head. So I'm pulling my calculator out. 15 times 350 is 5,250. And to solve for x, I divide both sides by 75. This left side crosses out. And 5,250 divided by 75 is 70. Okay, So there'd be about 70 if we looked at the entire group. Go back. So that would be our B answer right down there. Okay. All right. Hopefully that helped you guys out a little bit today. I'm not, again, not trying to, and I apologize for not everybody having the exact same questions, but